Hello, my name's Bastick. I'm an Excel MVP for my sins, and I'm also an accountant and a financial modeler based here in Australia, in Lockdown Central. Welcome along to my very brief session on an introduction to Let and Lambda, two new functions introduced to the Excel 365 fold that will go hand in hand, a bit like index and match, and baby and microwave. Okay, so my sense of humour is the same as it always is. Don't let me put you off that this is a shorter session. Let's get going, shall we? Let us start. Right, so there are two new functions or newish functions that have come in, and some of my colleagues are going to be talking about these in more detail. This is just meant to be a brief introduction because, I'm not as clever as they are. What I'm going to do is start first of all with the let function, which came out first, but both let and lambda are what are called generally available now in Office 365. So there may be functions you want to consider in terms of to going over to the subscription model as a consequence. Now, in essence, this function assigns values or expressions to defined names and passes these to calculation results. So it can store intermediate calculations, values, or defining names inside a formula. The defined names only apply within the scope of the let function in a similar way to variables in general programming scenarios. And I think this is an important thing here, that this is really sort of like Excel does code. And let is here just saying this is a name you put in, which is not universal like the other Excel range names out there that you can scope to a sheet or to a workbook. It's to this particular function. Now, when would you use this? Well, if you reuse the same expression multiple times in a formula, you've got to remember Excel calculates that expression multiple times. And that's not a good thing. Let allows you to name the expression and then refer to it using that name, similar to the VAR function or VAR in DAX, if you know what I'm talking about there. Any named expression then is only calculated the once, even though it might be referred to many times in the formula. And that can significantly improve performance considerably and speed up slow spreadsheets. So if you're finding spreadsheets are slow and you're calculating the same thing over and over and over again, this might be the function to you. That's what I'm talking about here. So how does let work? Well, here's the syntax. Let's try and explain what's going on here. So name1 is the name for the first value, and value1 therefore is going to be the value to associate with the first name. Not exactly rocket science, is it? We've also then got name2 is the additional name, so it's optional and therefore value2. And at the end, you have, not in square brackets, a calculation. So you need this. This is the calculation to perform. This is always the final argument, and it can refer to any of the defined names that have been put together in the let function. So the main benefits are readability and performance. So for readability, the let function tracks the changes in defined cells or expressions in a dynamic way. So there's no need to remember what a specific range or cell reference referred to. And with the ability to define variables, it can mean it makes it easier for users to follow what's going on. Although I can say as well, it can promote writing really long, horrible calculations all in one cell, which I'm not so sure about either. Performance, let allows named expressions in the formula, and therefore they're only calculated the once, even if it's referred to many times. So again, this is when you should really be looking at it. And I think the best way to go through this is with a convoluted LAMBDA example. Let's take a look. Right, with about 25 minutes left then, I thought I'd try and throw in 2 or 3 examples on let, even before we get to lambda. So let me give you the basic idea of let first of all. And I'm not saying you would use this this way, but it's just to show you how it works. So I've got here some data, the numbers 1, 2, 3, 4, 5, 6, and I've got the average calculated using the function average B3 to B8. You can say that's a very ordinary formula. In fact, it's distinctly average. Let me show you how I could do this with let. I just type in let, open brackets, and it wants a name for something I'm going to use as a variable. So it's like you're declaring variables. So I'm going to say here, let's call it data. And my data is going to be this, the 1, 2, 3, 4, 5, 6. And then what I'm going to do is just a calculation on this, which is going to be this average. So I'll just start typing in average and tab to bring it in. Then I'm not going to go average cells B3 to B8. I'm just going to type in data, which is the range name I've just defined. I've never been to the name manager. I've never gone and created it anywhere else. But if I press this, it works. Now, if I go to the name box up here, there is no name in here. We've just got B13. And if I go to formulas and I go in here to name manager and have a look at the names, I've got nothing in there. It's specific fixtures formula. So if I just go here equals data, I'm just going to get hash name. It doesn't know what it is, but it's worked it out within the context of the actual function. And let's try and help you make sense of what's going on. Now, in something like this would be convoluted, and you'd obviously use the first option, not the second. But it gets a bit more sort of something you might want to use when you've got something more complicated. So let's look at a second, more comprehensive example like I've got here. How about we use the property rental market, of which probably nobody wants any properties at the moment, given what's going on in the coronavirus city around the world. I hope you're all staying safe, healthy, and happy. Let's suppose we run a company where salespeople are going to make commission based upon 1% of the average of the square of the weekly rent. Yeah. Hello, Liam. You are doing rather bizarre calculations here. What on earth are you talking about? So let's say if Annie here, she makes two sales of $400 and $300, then the average of the amount squared would be 300 squared plus 400 squared, which is going to be 900. Oh, well, it's not 900, but it's going to be. Why did I choose such big numbers? 300 squared plus 400 squared divided by 2 will add up to what's it going to be? 160,000 and 90,000. Good example, Liam. Which is 250,000 divided by 2 is 125,000, and you get 1% of that is $1,250. Now, if you can follow that, I'm going to suggest that you're probably going to find Let and Lambda much easier, because I've come up with a particularly complicated way of doing things. But it's not much incentive, though, to make lots of sales, is there, because you're only taking the average the whole time. But it's not my fault she's negotiated her contract so badly. Anyway, I know it's convoluted, but I'm trying to construct an example. I can't simply use a standard function like average ifs or something like that. Okay, so let's go through. So I've got my business unit, salesperson, sales amount, and I want to actually work out what the commission is because it's broken down by a business unit for the salesperson at a particular commission rate, and I want to do it all in one cell. So I'm going to type in here, and I'm go equals, and I might make the formula bar a little bit bigger in a minute. I'll drag it down as we go through so we can have this a little bit longer. And when I do that, sometimes it makes Excel crash, which is always good fun. But let's go equals let, and we'll tab to make that bigger. And I'm going to define a range name called business unit. Now remember, we can't put any spaces in here because space is an illegal character. And remember, if you don't know the difference between unlawful and illegal, unlawful means to contravene or contradict the rules or regulations of the territory or jurisdiction that you're in, whereas illegal is a sick bird. Now, you can't put spaces in because that's not one of the things you're allowed to do with range names. And I'm going to have that business unit is going to be this thing here, but it has to equal C17. So I'm saying in here, I'm going to get false, 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 true, true, true. So if I do that in comma 1, just to show you, so it's just going to do this, it's just going to give me 1 here. It's not what's most exciting. But if I stole this in here, and I'm using, remember, dynamic ranges in here, if I go copy, Control C, take it out, what I've actually done here is gone equal, Control V, press enter, I get the false, 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 true, true, true. So I'm getting this range going on of falses and trues, so I can work out what is relevant for the actual commission rate and what it isn't. That's the whole point. Let's just get rid of that. So that's the first part done. See, so the let function does not have to have anything to do with what you've just defined. It won't give me an error. So let's just delete that. I'm going to press Alt-Enter to put me onto the next line just to go through. And I'm going to have now something called salesperson. And we'll define that salesperson has to be column C, therefore, so it's going to be all of these, has to equal Annie. So far, so good. And then Alt-Enter, put it on another line. I'm going to have selection, comma, and that's going to equal the business unit. Now notice business unit is coming up here, so I can press tab. It's already defined, so the IntelliSense is picking it up in here, so we can get that business unit times salesperson. So that can help you avoid typos in here. So we're going to multiply those two together, and then I'm going to work out something on the next line. Alt-Enter, called commission. And I'll try and spell it correctly. And the commission is going to be the 1%, C19, and then the sales amount is going to be these amounts here, D3 to D15, And then I finally got my horrendous calculation on the next line, which is going to be the sum product of the selection multiplied by the sales amount, and that's going to be squared, so I'll just make that to the power 2, close brackets, multiplied by the commission divided by, well, I'll use SumProduct, could just use sum here in case anyone, but I'm just trying to make it convoluted deliberately. Selection, and then we'll go close brackets, and that gives me my answer of $1,250. Now, that's a stupid formula. I know that this is not particularly the world's most exciting calculation or anything like this, but do you see that you can follow it and step it out all in one thing? And all these range names are only specific to this let function, not anywhere else. We've got this in here, it's looking good. And people can follow this, not in the formula bar. So when I talk about best practice modeling, I talk about consistency, robustness, flexibility, and transparency. And I feel that let does fail the transparency, but it's flexible and it's robust. And sometimes it's a balancing act in best practice modeling. And if people can follow this way, whilst they can't see it in the formula bar, they can see what all the names are defined, and I've not got them just sort of cluttering up the whole name manager elsewhere if I'm using them as a one-off. But you can see that, for instance, I've got in here the actual amounts could be used more than one time, but they'll only calculate them once. That's the great thing. So let allows you to see the definition of the name there and then without jumping somewhere else. Yes, the formula might be longer in the cell, but the user can hopefully follow it. That's the first thing. The second thing is when Excel sees a defined name in the formula, it pauses the current formula, evaluates that name, and then returns to the original calculation. Now, there is an issue with this. So whilst this might all seem like peaches and cream, let me just give you a subtle point here. Let's look at this key idea. Consider these two formulas here. I've got rand between equals 1 and 1,000 minus rand between 1 and 1,000. So rand between generates a number between 1 and 1,000, and then goes through it. So if I take this formula, and I'll just go here, and I'll just go Control C. Whoops, Control C. You know, I'm not a really good model or anything. Control C, and then down here, it's Control V for paste. I always wondered why it wasn't Control P, and then someone said, oh no, it can't be Control P because that's what you do when you can't go to the toilet. That gives me currently 76, so that's that. Now I can't press F9 here to actually recalculate, because if I do, it stops the video, which is actually what happened a moment ago, and I had to start again. Hilarious! But if I click on this 76 and go in here and press enter, you'll see it recalculates. It's dynamic. You can go and press the F9 function key. I've got to do it this way because of the software I'm using. And that's because the two rand betweens are independent of each other. They're both generating a random number. Now, if I take this one here and go through, and so I copy, and I put this down here and go paste, this is different. This is always 0 because it defines x as a random number between 1 and 1,000. So it might be 77, 153, 948, etc. But it just does it the once, and then x minus x is always going to be the two values are identical. So it doesn't matter how many times I press this one is always going to be 0. You see? So you've got to be careful when you use let as to whether you need it to calculate different things different times. So in simulations analysis, it might not be the most appropriate. But if you're going to be looking at something where you only need something to calculate the once and you want to improve performance, well, clearly let is a great function. But it's got a sidekick, the newer function, LAMBDA. Let's go take a look at that now. The second of the two functions I want to look at is LAMBDA. Yes, LAMBDA is now on the rack, and as I joke, not only Mary can have a little LAMBDA, we all can if we've got Office 365, as this has now become generally available too. Look, the power of this latest addition to the Excel family can't be overstated because it actually allows you to do things that you just could not do in Excel before. It allows you to make Excel what a programmers call Turing complete, whatever that means. Yes, I know you're all excited to hear that. And it Basically, it's a programming feature. It's been missing forever in the world's favorite spreadsheet software. You can actually create your own reusable formulae. So unlike let, which just defines a name and that's it specifically in context for let alone, Lambda actually is something that gives you your own reusable like user-defined function without having to use VBA. Pretty cool, don't you think? So how does Lambda work? And this is one of my favorite pieces of syntax. When you go in, you type in equals Lambda into the formula bar and you get Lambda parameter or calculation ... It's really, really helpful. You think that's really good. I can really follow what's going on in here. So let me just explain. Lambda allows you to define your own custom functions using Excel's formula language. So it puts it sort of free and easy for everyone. You don't have to have a PhD in VBA or JavaScript. In Office 365, it allows you to define a custom function nice and simply. Just one function can call another, including itself, and there's no limit to the power you can deploy with a single function call. So it's pretty impressive to put it together. If you create a Lambda and you call it custom one, for instance, you can actually use custom one within custom one. So you can get a function to call itself. It's pretty cool, don't you think? So I think maybe the best way is to actually have a look, what have we got to do? How do we get it together? And there's a 3-step process then, if it's so brilliant. You have to actually look, first of all, at what the Lambda function component is going to be. You've got to name it, and then you've got to call it. And I think the best way to do this is, guess what? Let's go create another example. Here's something I didn't prepare earlier. I always want to say that. It sounds good, doesn't it? I'm totally unprepared. Right, I'm going to type into this cell here equals Lambda, and you see Lambda comes up, and it's parameter or calculation. Great. And I'm going to type in here what I want it to do. I want it to take a variable, let's say x, and what I want it to go and do is I want it to add 1 to it. Not the world's most complicated thing. We have x as an argument. No, it isn't. Yes, it is. That is an argument, but that's not what I was actually talking about here. And x plus 1 is the logic or operation to be performed. So if x were 5, x plus 1 would be 6. If x were 23, x plus 1 would be 24, and so on. That's what it's going through. So let's press enter and just see how this works in practice. Oh, hash count, one of those new errors in here. It's not quite as simple as that. So what we've done is we've created the Lambda function components. We've done the first part, but we need to go further and we need to actually look at naming the Lambda so that it can be reused. So in order to go through that, we have to go up to the name manager. So, okay, we've got this thing here. So I'm just going to steal this or copy it. So I'll have to type it in a second time in a minute. And I'm going to go to the formulas tab and go to name manager here, keyboard shortcut, Control F3 to bring this up. Bit bigger so you can see in here if you want. I've got it in here and I can go new and say, right, I want to actually name this something else. So what should I call it? Well, I'll name it something else then. Again, can't have space in it. My actual Lambda x plus 1 and we'll comment my first Lambda. Oh, this is so exciting. I can't even get there, you see. I should have been here. I shouldn't be here. Get it? Shouldn't be? Oh, never mind. Anyway, so make sure you spell it correctly. To be clear, name is the name of the function. This is where you actually name it. I'll call it something else. So something else isn't the best thing, is it? Let's call it, I don't know, what X. Microsoft always call these things my Lambda. A bit boring, but there you go. A comment, so you can have that as a tooltip that will show up when you're calling it. So that's quite good to actually have in there. And then the refers to is where you put in your Lambda definition. So you put it here, not in the Excel function to begin with. More on that in a minute or two. And once it's completed, you just click the OK button. And there you go. It's in there, all happy, hunky-dory. And I can close. Liam, that was brilliant. So that's the first and second bit done. So we've gone through, we've had the Lambda function components identified, we've named it. Now all we've got to do is call it. So then we just call it like we do anything else in here. So I'm just going to start typing in equals my, and there it is, there's my Lambda. I go my Lambda and I put the number 5 in here and it puts 6. Oh my goodness. And just to prove that, if I just go here and use the formula text function in Excel, which shows me what I've written here, I've created my own little user-defined function in here. How isn't that good? Yeah, it's pretty cool, don't you think? You're thinking, oh, okay, so this is how you can create your own functions where you think, oh, I wish Excel did this, or I wish Excel did that, and so on. So you don't have to do it that way if you don't want to. What was wrong with this one? Why didn't this work? Well, it was actually pretty simple. If you hadn't gone through it, you can do it this way. You just need to tell it what's the value you want to put in here. So you do that, and then you say, well, okay, I'll put 5 in here instead, and then it would have worked. See, if I just copy that formula up, it's now worked. I just needed to put an actual value in. So the sky's the limit. You're not restricted to just numbers and text. You can also use dynamic arrays. So rather than passing a single value into a function, you can pass an array of values and functions, and they can all return arrays of values. And you can even use data types. The value stored in a cell is no longer just a string or a number. A single cell can contain one of what Microsoft calls a rich data type with a large set of properties as you want. So look, this is pretty cool. But you can go further with Lambda. So Lambda actually takes let a little bit further. You create a name that you can then re-employ. You're creating a function that can be used within this workbook. So if I go to another sheet and I type in here equals my Lambda 29, it still works. And if I put my Lambda sausage in here, I get hash name just like I normally would. You see, it just has exactly the same restrictions as others. But here's the rub. Here's something you can do with Lambda. You can't do it in Excel beforehand. Look at this. Here's the bit that blows your mind. Excel is now what's called Turing complete, which basically means you can do anything in programming. So it's programming gobbledygook. But essentially it means you can now do recursion. Now, if you don't know what recursion is, the best way to understand recursion is by understanding recursion. It's another joke. So recursion is something that calls itself, so it just keeps going back. And here's an example. Let's talk about triangle numbers. So if you look at the image in the bottom right-hand corner, I've got the triangle number for 1 is just 1. The triangle number for 2 is 1 plus 2 is 3. The triangle number for 3 is 1 plus 2 plus 3 is 6, and so on. Triangle number for 4, 1 plus 2 plus 3 plus 4, ad nauseum. Now, you can calculate this using a formula if you're clever, but you can use recursion and use the lambda. And so we could actually define a lambda as being, well, we'll name the variable x, that's what we're looking for, and say if x is less than 2, then it's just 1. That's what we'll do, so it doesn't keep going back forever. Otherwise, it's going to be x plus the triangle number for x minus 1. So it's actually going back. So what happens is triangle of 9 will take equals 9 plus triangle 8. Okay, well that will equal 9 plus 8 plus the triangle of 7, which will equal the 9 plus 8 plus 7 plus triangle of 6, etc., until you finally get down to 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus triangle of 1, which we've defined as 1. So when you add those together, you get 45. So it ends up calling this triangle calculation 1, 2, 3, 4, 5, 6, 7, 8 times. So perhaps not quite as efficient as the let function we were talking about earlier, but it's a way of getting recursion in there. So let's go and do this in Excel right now. So for this final example, I have been a little bit more prepared. I have actually put some stuff together and coloured in some cells. You see, are you impressed? I am, and I'm easily impressed. So let's put a number in here for calculating my triangle number, and it requires a positive integer number. Are you sure? Yes, I'm positive. So let's put number 4 in. And then I'm going to use the dynamic array function that came out in Excel 365 2 or 3 years ago now, sequence, which will generate in its most basic form the numbers 1 to 4 going down a column if you just type it in like that. So it'll just do that and go 1, 2, 3, 4. So do 3. You see how it just extends it. It spills it out. And if I want to sum that, which is basically what the triangle number is, I just highlight those here, but it puts G18 hash in there. And that means sum the range however much it extends. So if I put it to 5, you see it automatically extends. And if I press the F2 function key here, you see it's doing it there. And if I put it to 1, it's just, if I press F2 here, it's doing it to that. Pretty cool, eh? So look, if you can do it a simpler way, it's often a better thing to do it a simpler way, but I'm trying to show you how the actual lambda function works. You can also use a mathematical formula if you know, and the sum of the first n triangle numbers is n times n plus 1 over 2. So I could actually just go in here equals this number here multiplied by this number plus 1 all divided by 2 gives me the triangle number as well. So that is how you could do it. But I'm just trying to show you how triangle works and to show the idea of recursion. So in order to do that, let's actually go in here, and I'm going to need to go back up to the Formulas tab and Name Manager and go New in here, and we'll go in here and say, right, I'm going to call this my triangle number. So I'm going to call this, let's call it Triangle LB, because I've got another example in here already, so I'm going to call it Triangle LB to confuse it. You'll notice there's a few others in here. And that refers to, well, let's try and make this a little bit bigger so that you can see it, shall we? So I've got it in here. It's going to equal lambda, open brackets, and I'm going to have x is going to be my variable, and then if, open brackets, x is less than 2, then I just want it to be 1. Otherwise, I want it to be x plus triangle, this thing, of x minus 1. And then I close brackets on that. Then I need to close brackets on the if statement. And finally, I need to close brackets on the lambda. And so that gives me my actual wonderful formula here, just in there, and click OK. Let's put it in. So I've got those, and you can see I've got some others in here because I've got other examples, which is why I've had to call this one Triangle LB. Great. So what? Well, now I can just type in here triangle, and we'll put in here LB, it's the one I've done, of this number here, G12, and that gives me 10. And if I change that to 7, it gives me 28. So I'll just put this down so you can see what I've done. That is it. I've created a recursive formula, a formula that calls itself. And I've defined that in the Name Manager. Pretty impressive, don't you think? Now that's really all I've got time to actually show in here, and I'm sorry it's a brief one, but some of my colleagues are also going to show you wonderful things you can do with Let and Lambda that sort of take this to the next step. The one thing I just wanted to mention in passing, and please check out our website, SumProduct.com. It's all free on there, no sales pitch, nothing in here. I've got an extended version of this where I actually show how you can actually create this wonderful formula on the sheet itself and the attempts you have to go through to get it to work, and you start using a name called me where it sort of calls itself. Now unfortunately in a 29-minute session I don't have time to do that, so I haven't got through here, but you can see the various attempts that if you just put in the actual lambda in, you get cache calc. If you then put the number in, it gives you name, because the problem this time is it's calling itself. So then you wrap it in a let, saying, well, if I wrap it inside a let, I can then define the name, but it still doesn't quite work. And what you then do is you have to create a kind of like a dodgy function in the middle, and eventually you tweak it and get it right. And unfortunately, I don't have time to go through all the nuances of this here, but it is possible because people ask, do I have to use the Name Manager to do it, or can I just write it in the cell? And you can by combining let and lambda. But as I say, just introducing it here is a little too much. But if you go to the SumProduct.com website, and you look up let lambda recursion, you'll see this example in here, and I will actually talk through in much more detail what goes on. Okay, that's the end of my examples for now. Let's finish. Thanks for watching this session. I hope you enjoyed it. If you did, my name's Bastick. If you didn't, my name's Cristiano Galval. Here's my contact details should you want to get in touch and ask any further questions. And do check out our website, SumProduct.com. But for now, hope you're enjoying Excel Weekend 7, and hopefully I'll see you next time. Thanks, Cristiano, for inviting me, and hope everyone is enjoying it. Bye for now.